Machine learning is a subfield of artificial intelligence that focuses on developing algorithms and models enabling computers to learn from data and improve their performance on tasks without explicit programming. Historically, people used to write code and put rules in the code in order to complete a given task. Right now, what happens with machine learning, data is given to an algorithm, which then learns everything about the data and is able to perform a specific task based on what it has learned from the data. That's the beauty of machine learning today, that you can provide data and then the algorithm will learn all the aspects about the data, all the patterns in the data, looks at all the examples that it has, and it's able to make decisions based on the data that has been provided. For example, previously, we would set rules in your code. Let's say if an animal had 4 legs and whiskers, then it would classify it as a cat. Another rule you'd put in your code would be something like if the animal had 4 legs and pointed ears and hanging tongue, then it would classify it as a dog. Today, all these patterns about the animal, the patterns about the ears of the cat, the eyes, the whiskers, all these, if you provide these images to an algorithm, all this data, it will be able to understand that this is definitely a cat or this is a dog, basing on data provided for itself. And that's the beauty of machine learning. So deep learning itself is a little bit more advanced. It's a subset of machine learning. Basically, deep learning will use what they call neural networks. We shall get into detail what a neural network is. Basically, neural networks get to understand patterns of different items to help in learning all from the data that is being given. So, as we go further, we will get to learn that we can use examples of machine learning systems. For example, linear regression. In this case example, we're going to use a simple machine learning algorithm called a linear regression algorithm. For example, you provide data to the algorithm, different points of data, and the algorithm will find the best line of fit of these data points and be able to make predictions. That is a simple example of what it can do by finding the best line of fit. How would it do that? It gets find the best line of fit between all the data points. It will minimize the error between predicted values and the actual values that you provided it. We'll get into all that where we'll have to understand the weights and biases as we go further into the course. So basing on this line of fit, we'll have found the minimum errors between the points and this line, which is normally referred to as a line of best fit. When you have all plotted all the points, let's say on your graph, this will be the best line such that there's a minimum error between each of the points and baseline of fit. Let's show you a little bit of mathematical representation. Let's say we have the formula y is equal to mx plus b. Let's say y is going to be the predicted value, m will be the slope, x will be our input features. An input feature can be, for example, we could say the price of the product, and b will be the intercept. So if you have several points of data, we're able to find the slope. If you plotted the graph, we already have the prices of items, and then we'll be able to find the intercept. This is what we usually do in linear algebra, to be able to find the predicted value. This is a simple example of a linear regression model which is being used. For example, if we found m, the slope is found to be 6, and the intercept is found to be 9. So we could use this formula this algorithm to make predictions of prices if X was for price. Next, in our final algorithm will be, the model will be Y will equal to MX plus B, which is Y will equal to 6X plus 9, based on our computations. We'll get into details more on how to find these numbers. Okay? So, in simple terms, if we graphically represent machine learning, we realize that the bigger circle is what we call artificial intelligence, and within it we have machine learning, and within machine learning we have deep learning. Remember, we said deep learning involves the use of neural networks. But generally, machine learning and deep learning are both subsets of what we are calling today artificial intelligence. So, as we had mentioned a little bit about deep learning is a subset of machine learning that uses artificial neural networks with multiple layers, hence deep, to learn complex patterns, especially in large amounts of unstructured data, for example, images, audio, and text. What does this mean? We will have a graphical representation later on of what they call these neural networks and layers. Basically, when I'm talking about unstructured data, usually we have structured data where we have tables. For example, in Excel files, we have tables where you have different rows that are well organized and well structured. But when you're dealing with things like images, we don't have tables. This is where it comes in handy to use what we call neural networks in understanding the patterns in data. If you have different audio messages, that is unstructured data. We'll get into that later on and apply them. So, a simple description of a neural network is a machine learning model inspired by how the human brain processes information. It is built from layers of connected nodes, also called neurons or units, that work together to recognize patterns and make predictions. Neural networks are like tiny helpers working together to solve problems. Examples of deep learning. We have image recognition or facial recognition. We use this to recognize faces on cameras. So every time you see somebody being recognized, you know that's part of deep learning. We have language translation. If you look at sometimes these apps on your phones that translate from, for example, from Luganda to English or English to Luganda, that is all part of what they call natural language processing. We will get into that on how to, and also how to build some of these. We also have these email spam filters. Some of them, for example, figuring out whether one email is a spam or one is an actual email, good email. All that is part of machine learning. Just as we mentioned, translating from speech to text, you provide the algorithm with a speech and then it produces you an output. So a few key characteristics of algorithms. One, they're data-driven, meaning you provide it with examples, you provide it with data that it's going to learn from on its own. Two, what they call generalization. It aims to perform well on new unseen data. Basically, basing on what it has learned, the patterns it has learned from the data you provided, from the information you provided it, it's able to look at new data that is completely new to it and solve a problem. For example, if you provided it with several prices of stock, like let me say the Tesla stock, it's able to look at all the prices and come up with the best model to make a prediction for the price. So you provided it the data from 2000 to 2010. It looks at all the data of prices of Tesla stock. And then when you provide it the data for 2025, it should be able to make a prediction because this is data it has not seen before. It saw data from 2000 to 2010, but if you give it data from 2025, It should be able to generalize, make decision based on new data. So another aspect about an algorithm, adaptability, can improve performance when retrained with new data. So we are always retraining these models because circumstances are always changing. So updating our algorithms by the mere fact that we give it more recent data or more data or better data. Task specific. Some models are trained for a particular problem, for example, spam detection or price prediction. So we shall now go into the mathematics of the model.